Hey guys, this is the Phantom of Guitar speaking. This is my first video I actually speak. I uploaded a video in the past. I speak about how I write music in FL Studio, but today I'm going to make a serious video about the science behind music. This is the first episode of Science Behind Music. I try to share my experience about electronics and programming, knowledge behind signal processing and music industry. It had lots of fun for with me. Sorry, I just mispronounced some words. It had lots of fun for me, and I really enjoyed programming synthesizers. I really enjoyed making hardware for producing music or processing the signal coming from the guitar or any other instruments we may use. Okay, in this video, I'm going to talk about distortion plugins or overdrive plugins or pedals. You know, the pedal and plugin do the same thing, but today I'm going to talk about the hardware. Later, I may make a video on how to process signal using some lines of code and make this clean guitar signal I recorded. It's just a pentatonic nonsense I recorded from my guitar to have a simple audio sample for what I did. Okay. Well, I designed this circuit. I actually didn't design that. I find the design on the internet. I found it very useful. I put it on the test and it worked. I didn't made this circuit in real world, but as I passed some signals through the circuit, it just gave me a distorted sound. But before I'm going to put the circuit to the test, there are some components here you can change to get different amounts of distortion, I believe. For example, you can replace one of these resistors. I'm sure this resistor here is responsible for the amount of distortion caused by that transistor and this part of the circuit, of course, because if you have a little knowledge on electronics and electrical engineering, I'm not an electrical engineer. I studied computer hardware engineering, and we had some courses in common with people who study electrical engineering. Sorry for my accent. I'm not a native English speaker. And as you can see, the resistance of the capacitor is lesser than this resistor, of course. And when the current flows through this transistor to the ground, it finds this way much easier to travel to the ground. And the capacitor is responsible for making a distorted sound here, I believe. I didn't study the documents behind this circuit. I just found the working example on the internet. I hurried up, you know. I really I'm really sad about that, why I didn't study how it works. But I believe this transistor acts like a switch here. We applied a voltage here. If you have a pedal in your gear, I'm sure you have, most of guitar players and most of musicians have pedals. The pedal may have a power supply like this. You feed the voltage to the circuit using a battery or an external power supply. Okay, before going to test this, I explain why I make these series of videos. I made a video from Monochrome Seasons. I don't know why he made that video, but he explained a lot about DIY circuits and how to get popular on YouTube. It was like a live video, but it wasn't a live. I don't know about that YouTube technologies. Okay, guys, okay. So I don't waste time anymore. The software I use is called LT Spice. It's a free piece of software made for Windows, but it's fine on Linux. I spend most of my time in Linux unless I want to make music. This voltage supply here is actually my supply to apply the guitar signal into the circuit. Why? Because when you hit the strings of your guitar, it generates a very small voltage, and the voltage is actually in the frequency of the note you are playing. If you play a note A at the frequency of 220 hertz, here we will have a very small voltage, and this circuit just distorts that signal and feed it to an amplifier if you set your distortion pedal in the preamp setup. Okay, so I right click on this. I'm going to advanced DC value. I type wave file. Why I use Z? Because I'm running this piece of software on Wine, and when you want to access the main file system on your Linux machine, you should use the drive Z. I don't know what's the reason behind that, but it works. I hope it works. Home prp-e documents, and the name of this folder is dist pedal, short for distortion pedal. Let's listen this. Yes, I just plugged in my guitar to my sound card, which is a Scarlett Focusrite, which is a Focusrite Scarlett Solo. Sorry. And I recorded this piece. Clean guitar.wave. Clean guitar.wave space chan equals to 0. Chan is short for channel, from the channel number 0. Okay, you know, the amount of the voltage changed to this. Let me move this text, this piece of text here, so you watch it better. Wave file z home prp-e, which is my username, documents dist pedal guitar clean guitar dot wave from the channel 0 on this setup. Okay, I have my audio injected in, and let's do something here. I click here on this operation, and these are spice. I don't know what is a spice actually. I know it's short for some other terms, but I forgot that. And here I type dot wave. Every spice command starts with dot wave home prp-e documents dist pedal dist guitar dot wave, and then I add a few numbers to this. The first is 16, which is the bit rate of what I'm going to make in the output of my circuit actually. Then I use 44100, which is the sample rate of my signal. Later I make a video about how to create a synthesizer in the programming languages like Python, and I'll explain why we use these huge numbers as our sample rates. Okay? And the 0, which is our channel, And then I type out, which is my output here, and I hit OK. I put this command under this line. So as you can see, I have an address to a WAV file in my file system on my machine, and I have a comment which commands the program to create a WAV file there. And now I'm going to edit simulation commands. Stop time, I don't know how long is that. It's 8 seconds, okay? Stop time, 8 seconds. Time to start saving data, 0. And maximum time step, 8. I click OK and I put it here. So if I click this run and I start probing these wires, I get two different signals. One is the clean signal from my guitar and one is the distorted signal from the circuit. Let's do it. You know, this is the clean signal, and the blue one, which is the output signal, is the distorted signal. I believe if I zoom in, you can see it just affected a bit. Not that much I hoped for. You know. Sorry, it got to 0 volts. Okay. So I have a distorted guitar signal here. Let's listen to it. What's wrong with the circuit? I heard something in my headphones here, but okay. I have two rendered signals. Let's try it for now. What's wrong with that? Let me show you. You know, there is nothing recorded in this. I think I need to label the input wire here. Label net input signal here. And as I feed it to my circuit, you know, I'm sure the circuit is fine and works well because I tested it before using the signals I just added to this power supply or the input signal here. So let's test it again. Okay. It's empty again. I don't know what's wrong with my design. You know, this is my reference, and oh, my bad in my comments. You know, this wasn't necessary. This 0 wasn't necessary. My bad. Sorry guys if I wasted your times. You know, I just came up with this feature in LTSpace last night, and I couldn't really test it well. I was too sleepy. Okay. And as you can see, those signals are are being written on the plot here. What the hell is wrong with my... You know what's wrong with my application? I tell you here. These applications only work in the range of -1 volts to 1 volts. And if you look close here, it reaches around 3 volts. Don't do that. I don't know how I can do that. Maybe adding some more resistor here. Let's try it. Adding a resistor just affects my signal, but not that much. I just add a resistor to decrease the voltage level. You know, it's not safe. It wastes lots of power from your circuit. So, you know, this is the duty of the mixer, audio interface, or sound card you connect to your computer to keep that voltage level safe. If I add 1 kilo ohms of resistance, it kills lots of power there. So I add 230 ohms of resistance. Okay? So let's test it again. Again, it's there. What the hell? It just decreased a bit. Sorry, the video is getting too long. And yes, I'm going to change the resistance of it to around 2.5k, and it would work. It's around 2 volts. I need some regulation to keep it around 1 volts. I don't know how a regulator circuit will work. But wait, I have an idea. The idea is to remove this resistor, not transistor, my bad, and then decrease the voltage level at the power supply to 5 volts. You know, this is one of things I find the hard way. Why? Because I was too lazy to read the description of this circuit and to understand how it works. Don't be like that. This is here my input, and my output is, you know, just around 1.5 volt, much closer to what the software like Audacity can handle. Let's listen to it now. You know, still nothing. I should keep it close to 1 volt of potential difference. So the last voltage I'm going to try is 3.3 volts. And why? Because every circuit includes a regulator which can decrease the voltage to 5 or 3.3 volts in these applications. I forgot that. I totally forgot that. And yes, it's in the range of 1 volts. So this circuit works well in the range of 1 volts. And as you can see, it seems like a distorted signal. Let's zoom on a little piece of that. Yes, let's listen to that. That's more like an overdrive to a distortion. Why? Because I think the voltage was higher than what it should be there. So guys, if I find any useful sources on how this circuit works, I will post it on Facebook, or I will post a YouTube video later to show you how this circuit actually works. Thanks for watching. This was my first video on science behind music. The video is weak. If you have any suggestions for me, please tell me in the comments. Please like, share, and subscribe to my channel. And again, thanks for joining me here.